Hello again, welcome to my science channel. I promised you last time that I'd show you a little pyramid that can help you work out the transpositional formula for Ohm's law. And here it is. If we write V and I and R on the bottom, you should recall that V is for voltage, I is for current, and R is for resistance. And if you cover up any one of those, the ones you want to find, for example, if we wanted to find resistance, we cover up R, and we could say R is equal to V over I. It would be R is equal to V divided by I. And similarly, if we wanted I, we cover up I, and I would say V over R. And lastly, if we cover up the V, it shows us that V is equal to I R, or I times R, if you like. If you don't put a sign in between the letters, that insinuates a multiplication. And that's the easy way of doing it. So today we're going to look at the two different ways you can connect resistors into a circuit. And first of all, we're going to look at the series connection. So that's series. And to put resistors in a series is going to be like this. It's just basically connecting them end to end. The square, as I've said previously, is the symbol for a resistor. And we can call this one R1, we can call that R2, and we can call that R3. Now, if we wanted to work out the total resistance of this circuit, it would be RT. The T hasn't got any number at all in it. We're just using a subtext T to state that that's the resistance total. So is equal to R1 plus R2 plus R3. And you can see when we connect resistors like this, the resistance of this circuit is going to continually increase with the more resistors that we put on. The second method of connecting resistors is the parallel connection. And the way we do this is if we have these resistors, and we connect them like this. Well, that's a parallel connection. And we can call this R1, we can call this R2, and we can call this R3. Now, the way we calculate this one is going to be 1 over RT, T for total resistance again, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So that's the way we go about this. But if you look at this now, you have these resistors, and what they're doing, they're giving the current additional paths through them. So what we'll find is the total resistance of this circuit is going to be less than the smallest value resistor that we've got connected in. And that's a good rule of thumb to check your answer, because if your answer is larger than any of these resistors, then it's going to be wrong and you're going to have to look at it again. But let's look at a real life example. So what I've done, I've got 3 resistors drawn on some paper, and first of all, if we connect these into a series configuration, we've got 15 ohms, 10 ohms and 6 ohms. And what we want to do is work out the total resistance of this circuit. So the formula is going to be resistance total, RT, is going to equal 15 plus 10 plus 6. So simple addition, we can say the resistance total of here is equal to 15 and 10 is 25, and 6 is 31. So that's 31 ohms. So if we now take the same group of resistors and connect them in parallel, so we can say our 6 ohm there, and our 15 ohm, and our 10 ohm, like that. And we connect these now in parallel, like this. Now let's try and work out the resistance total of that. So if you remember, we said that 1 over RT is going to be 1 over R1 plus 1 over R2 plus 1 over R3. So if we want to populate the equation with our figures now, we can say it's equal to 1 over 6 plus 1 over 15 plus 1 over 10. And we can employ our little calculator now in this. So all we do is we say 1 divided by 6 equals 0.16. I'm only going to go to 2 decimal places. And then for the next one, we say 1 divided by 15 and equals 0.06. And then plus, let's go and find the last one, 1 divided by 10, and that equals 0.1. So we can say 1 over RT is equal to the total of these. So that's 0.16 plus 0.06 plus 0.1. So that gives us a total of 0.32. But we haven't finished there, because that's 1 over RT. We don't want to know what 1 over RT is, we want to know where RT is. So our final move, RT, is 1 divided by 0.32. So we'll just pop that into the calculator. 1 divided by 0.32, and that equals 3.12. So resistance total for that circuit is 3.12 ohms. And is that smaller than the smallest resistor? It is. Our smallest resistor is 6 ohms. So that's a lot less. So that seems to hold water. So that's how you calculate series and parallel resistors. Now what I'm going to do is give you an example for you to do yourself. What I want you to do is have a try of this. So if we have 3 resistors of values 5 ohms, 7 ohms and 12 ohms, what I want you to do is draw the circuit and do the calculations of these resistors, first of all connected in series and then connected in parallel. So what I'm going to do is I'm going to go through the equations with you, but first of all, if you push pause, have a go at the question. If you push play again, we'll go through the answer. If we do the series first of all, so series, the resistors are going to be connected like this. That's going to be 5, 7 and 12 ohms. Oh, we can stick the omegas in if you want. 12 ohms. And we know that RT is going to equal R1 plus R2 plus R3. Doesn't matter which resistors are R1, R2 and R3, but we'll just go up like that. So we can say RT is equal to 5 plus 7 plus 12. So that would give me a resistance total of 24 ohms, just adding these guys together. And the second way we're going to do it, if we connect these in parallel, we're going to say that our resistors now are going to go like this. And we can say 5 ohm, 7 ohm, 12 ohm. And so we've said that 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So if we populate the figures, 1 over RT is going to equal 1 over 5 plus 1 over 7 plus 1 over 12. So 1 over RT is going to equal, so if we just pop these figures in, 1 divided by 5 equals 0.2 plus 1 divided by 7 equals 0.14, and 1 divided by 12 equals 0.08. So 1 over RT is going to equal all these added together. So it's going to be 0.2 plus 0.14 plus 0.08, which equals 0.42. As I said earlier, we haven't finished there. So we need, that's 1 over RT, so we need RT is going to be 1 over 0.42. So RT is going to equal 1 divided by 0.42, and that equals 2.38 ohms. Is that smaller than our smallest resistor? Our smallest resistor is 5, so that's a good indicator that we're on the right track. Now, if you are going to follow through with us with these calculations, then what I would suggest you do is you get a little book, a little exercise book, or a loose leaf pad or something to that effect. Because what I'm going to do is I'm going to use these examples when we talk in the very near future about calculating the current in the circuit, and we're going to use these for resistor values with some voltages that we'll add in, and then we could do some voltage and current calculations using Ohm's law in these circuits. I hope you've enjoyed that. Subscribe to the channel, and as I said previously, if there's anything that you're unclear of, put it in the comments, or if there's something that you'd like to see me do, put that in the comments as well. Thank you very much.